Hey guys, welcome back. In the last few videos I was showing you how to do TCP data transmission, a trivial example, but since we're trying to catch a cookie thief and we need to monitor our temperature and let the people in the house know when the temperature in the kitchen isn't right, we need to take temperature readings and turn on an LED, a practical example of using this. And so that's what I'm going to show you how to do here. So the equipment you're going to need to do this is, of course, 2 Raspberry Pis, one here and I have one here, and they're both connected to the Ethernet through Wi-Fi. This here, above this imaginary line, is the circuit that detects temperature. You'll recognize this chip and this wiring configuration from the analog sensor tutorial that I made earlier. And this here is a TMP36 temperature sensor that will be read to detect what the temperature is in this like fake kitchen setup. Over here, lower, is another circuit, completely isolated, that is turning on an LED, and I did a tutorial on how you can do that earlier as well. So the idea of this project is when this temperature sensor detects that it's too hot, this LED comes on and blinks for a few seconds before turning off. That's the idea, that's the project, and so we're going to set that up. Now, if you've been following along, there are going to be some scripts that have already been written, and we're going to be using those scripts in the interest of speed and kind of like taking them apart and modifying them a bit. And so we saved all our scripts in the cookie folder. So right now I'm on my Play Pi. This is the Pi that is connected to my sensor, and the first one we're going to open up is Cookie Client. Now, because I said that I'd make all of these files available online, I'm just going to save over Cookie Client right now as Cookie Client 2. So this is like our new and improved version, so that if you want to revert back to the trivial example, the original Cookie Client file is still there for you to access. So we are already setting it up with a host and a port and all that. One additional package we're going to have to import is, one more function we're going to have to import is from time. We're going to import sleep, because we're going to need that as well to do this. So we're going to have to do quite a bit of changing here. So we have our host and our port that are specified, and then I want to define a function called setupSocket. And you can probably guess what setupSocket does. It, well, sets up the socket. So these are the lines here where we set up the socket. So we're going to set up our socket, and then we're going to connect to it just like before, and then out of this we are going to return S, which is our socket. Then we're going to want to create a new function, and that new function is called send receive. So this is where we send our data and we receive our data, and into it we want to pass the socket and the message that we want to send. So I'm just going to rewrite this. What we want to say is, here, let's get rid of this while true statement. We're going to delete that later. But with, oh my goodness. In send receive, we want to take our message that was passed into it, and through the socket that we also have passed into it, we want to encode that message and send it out. Once we send it out, we're going to get a reply back. This might look familiar, and our reply back is going to be receiving, and I'm going to have a buffer of 1024 here, and you can change yours to whatever you feel is appropriate. And then dummy statements just saying we have received a reply, and then we're going to, because we want to shut down the connection when we're not using it, this allows other Pis to connect or whatever. It doesn't take up resources, and if the program were to crash, it doesn't crash the server. So we're going to want to disconnect, so we're going to send closing message. And remember, on the other script we already had a command written called exit, and that exit allowed the client to disconnect safely. So we're going to send that message, and that message is exit. And then finally we are going to close our socket because we no longer need it, and then we are going to get we have our reply, right? So we have our reply and we want to decode our reply, and we want to decode it in form UTF, oh, not WTF, UTF-8, and then we're going to return out of this our decoded reply. So there we go, excellent. So now we have a function that we can call on that will quickly send out the message, get back the receiving message, send out the close message so that we cut the line, so to speak, we close the socket, and then it passes back the reply. Finally, we're going to create one last function here called transmit. And transmit is going to be the function that is called on when we import this as a module. Cookie client 2 is going to be imported as a module, and the message here is whatever we're passing into the module, so that, like, this is what's being called on. So now this module is just like a trivial send receive kind of thing, where it opens it up, sends it out, receives back, and then closes down. That's the idea. So I have to get our socket, and socket is going to be equal to setting up our socket. Oops. And then we're going to have a response that's given back out of send receive, and that response is equal to receive. We pass in our socket and we pass in the message. So now we have a response, and then we're going to return our response, and that's it. So I'm going to delete everything that's left over from the old cookie client, and there we have it. So assuming that there are no typos here, we're going to, and I'm sure I'll find out when I start launching this program and it starts crashing on me, we now have this file open called cookie client 2 that we can call on the transmit function to send the data out, receive the data, and then cut the connection. The next thing we're going to want to do is we're going to want to write a script for our analog sensor that we can also call on, and this will be called on from our main function. So I'm going to open up the cookie analog here, and because I used this in a previous tutorial, I'm going to again save over it and write it as cookie analog 2 so that you guys can download it and download the original cookie analog. So I'm going to save it as cookie analog 2. Now, there's a few things here we can get rid of because we're only worried about temperature now, and we're not worried about anything else like humidity or light or whatever else I had connected to this. We don't need to sleep. We do need to open up the SPI bus. What sensor is where? Well, this particular, let me just kill my phone here. This particular configuration that I have here, I have the temp channel set to 0. We no longer need our light channel because we don't have a light sensor. And we're no longer going to be needing to sleep, so we can get rid of our sleep time here. We're going to need to continue having our get reading function. We don't really need convert voltage anymore because we don't care about that in this particular setup, but you might. Convert temp we'll definitely need because we need to return that temperature. So what we can do now is instead of having this like while true loop, we can define a new function called getTemp. And what getTemp will be is we'll get a value called temp data, and this is a lot like before. Temp data is going to be equal to get reading, and then we pass in temp channel, just like before. So now we have our temp data. The next thing we're going to need is our temperature, because that's what we're concerned about, and our temperature is calling on the convert temp function, which is passing in temp data. Finally, we're going to return out of this temperature. So just deleting everything that was in the while true loop, we no longer need that. That's no longer relevant. So if you want this system to work on your voltage, you can change it so that you have voltage, but because I'm concerned about temperature, this is all we need for our new analog sensor Python module. So that's called cookie analog 2. Now, to be able to use these two modules, we're going to have our main function call on them. So I'm going to open up what was cookie main. Now, because in another tutorial I showed you what cookie main is, again, I'm going to open this up and I'm going to save it over as cookie main 2 so that we are, you know, we're moving one step at a time and you can look at the old files. Alright, now that we have our new cookie main 2 saved, the next thing we're going to have to do, of course, is set up some new imports. And these new, or new packages to import, I should say. So we're going to first have to import sleep from time import sleep. All right, right. Okay, we're also going to have to import from, what did we call it? We called it cookie client 2. Yes, we called it cookie client 2. We're going to import transmit. So that was that function that we made. And from cookie analog 2, we're going to import, what did we call it? We called it get temp. So now we have all this stuff here that we don't want to use in this particular tutorial. We'll put it all together in another video. We're just interested in getting the communication for lighting up this LED happening. So we're going to want to define a new function here. And our new function is going to be called temp monitor, because we are monitoring our temperature. So let's get some dummy statements in here just so that we know that it's working. We are about to take a reading. And so if we want to take a reading, we want to save our temp value as something, and our temp value is going to be the float of calling on that function get temp. And then we're going to want to print, again, a dummy statement, our temp is, and then we can say plus string temp. So now we've taken our temperature reading, and now we can make a decision, and I'm going to make this decision in this function where we say if the temp is greater than, let's say, float 22. So if it's above 22 degrees Celsius, we are going to say, we're going to create a message, and this is the message that we want to transmit. So our message is equal to LED underscore on. So turn on, the LED is the message. We're going to print transmitting data. And then we're going to say our response, which is what we get back out of the program, is going to be whatever transmit data or transmit our message returns to us. And then we're going to print that. We're not going to print message, we're going to print response. Right? Okay, so what we're doing is this function gets a reading, so it calls on get temp, gets that reading, compares that reading against 22. If it's above 22, we then send out the message to the other Pi and say, hey, yo, turn on your LED. Scrolling down here to our while true, because we are not concerned with the overall performance of our program just yet, I'm going to comment out all this stuff we wrote in the past. And instead, what I'm going to do is I'm going to take a reading from our temperature sensor, so we're going to get temp monitor, and then we're just going to sleep because we don't want to go crazy. And we're going to sleep for sleep time length, and I didn't specify what sleep time was yet, so we're going to have to add that variable, and I'm going to add that at the top. And so our sleep time is equal to 3 seconds. Alright, cool. Now I'm going to give that a save. So there we have it for the PlayPi side, and this is the side that reads the temperature. Now what we need to do is get it running on the other Raspberry Pi, the Grow Pi. We need to get our server set up, and we need to write a program for it to blink an LED. So moving over to our Grow Pi, which is, this is the Raspberry Pi connected to the LED. We're going to open up our desktop, we're going to open up our cookie folder, and we're going to open up cookieserver.py, and this is the file that we created in our last video. But actually, hang on a second. Before we do that, let's create a new one. Because I don't want to use the cookie server to turn on the LED, I'm going to create a new file that will turn on the LED, and this will be a module that we import. So I'm going to save this as cookie led.py. I don't know if I've used this file name somewhere else, but I'm going to call it cookie led.py. And this is going to be the script that turns on and off the LED. So just like in the introduction video that I made earlier, we're going to have to import the GPIO as GPIO, and then because I want to keep the LED on for a certain amount of time before it turns off, we're going to from time import sleep, which I could use some of right now. We're going to specify our sleep time, and I'm going to say 5 seconds so that we leave the LED on for 5 seconds, and our LED pin is equal to 40. As you saw when I wired it up, yours may vary. We're then going to define a function called LED setup. We are in the LED setup, we're going to GPIO.setMode, and we're going to say GPIO.board, so it knows what configuration of pins we're going to be using, and then we're going to GPIO.setup, and we're going to pass that the LED, lowercase LED pin, and we're going to pass it we're going to specify that it is a output. So now we've set up our LED, and then we're going to want to specify a new function here called LED on. And in this one, you can probably guess what's going to happen. We're going to say set our GPIO output for the LED pin to be true, that is, make it on, and then we're going to sleep for the amount of time that we want to leave it running, which is our sleep time, and then finally, because we are concerned about safety, we're going to clean up our GPIO board, or header, so that all the pins are neutralized and go back to a safe state versus putting it low. So it's kind of like we're turning it off versus we're just temporarily or indefinitely keeping it in a low position, which is something we don't want to do. And then we're going to create a function called call LED, and it's just going to run the LED setup, and then it's going to run LED on, and that's it. So the idea is we can call LED, and then it runs through the setup, and then we have this here working. So great. So now that we have that, okay guys, just a quick correction to my cookie LED one. We're not actually wired up to pin 40, we're wired up to pin 12. I knew I'd make a typo somewhere, and I think this is because of my script having 40 on it, and I didn't even think about it. So we want to make that correction. Let's just minimize this to avoid confusion. And in our cookie server file, I'm going to save this as cookie server 2 so that you can access the files, because I'm going to be overwriting some stuff. Now, if we're going to want to call the LED, we're going to have to, from, what did I call it? LED, cookie LED. From cookie LED, we are going to import call LED. Cookie LED, we're going to call LED. All right, excellent. Now that we're on top of this. So this we don't have to make too many changes here, but what we do have to do is add in a command down here in our statements where we say else if our command is equal to LED underscore on. Well, you can probably guess what we need to do. We need to call our LED, and then we want our reply to be equal to LED was on, right? So that's what we need to change. Relatively small changes, because it's the same server, and because we wrote a completely different script, we can just call on it, right? And that's the reason why I chose to set it up like this. So we're going to be importing the call LED function from cookie LED module that we wrote on the server side, which will turn on the LED when we need to do that. Now theoretically, we have a server side that's set up properly, and we have a client side that's set up properly. So the first thing we need to do, this is our play pie. So on our grow pie, now it is time for the moment of truth. We have our sensors wired up and we have our script files written. So now what we want to do is we want to call using our sudo command, because we're going to be accessing the GPIO with cookie LED. We need to use sudo python3 to call on cookie server2.py. So this will set up the server, and there we have it. The socket is created and the bind is complete. Still didn't fix that, oh my goodness. And on the play pie, we're going to want to call cookie main. So python3 cookie main 2.py. So now this is going to start reading this sensor, and it was somewhere like 22 or 23, I can't remember what I specified, is when we flip. So here, when I touch the sensor, the temperature should go up. There we go, and there we go, transmitting data, and the LED comes on, waits for 5 seconds, goes off. We then take a new reading, 25.8, transmitting the data, LED comes on. Isn't that cool, guys? Come on, that's so cool. You know, guys, that is cool. So now we are communicating over the Ethernet, over Wi-Fi, to Raspberry Pis, where one is taking sensor readings and the other is reacting to those sensor readings somehow. And this is not trivial. This, of course, can be extended to doing it over the internet if you really want it to be cool. For example, I don't know what you would do over the internet, but you could, off of your smartphone, you could send a message to your Pi through socket transmission to say open up the front gate at your house, or turn on the lights, or turn on the air conditioning, or something like that. And that's all there is to it. And now we see our temperature reading has dropped back down to below whatever that float value was that I specified, and the LED is not coming on. So I hope this kind of illustrated a practical example of how to use socket transmission and 2 Raspberry Pis to actually accomplish something that's pretty cool. In my next video, I'm going to show you how you can transfer a file to another Raspberry Pi through Python automatically, because if we're going to catch our cookie thief and our cookie thief sees our little breadboard system there on the counter, he might steal it, right? And then the pictures are stolen, and then we have a problem. So we want to be able to automatically send a picture over the Wi-Fi, over Ethernet, to another Raspberry Pi to act as a safety repository. And I'll see you in that video. I hope you have enjoyed the series so far. Thanks for watching.